All right, so this one we're going to look at is what is a cone, and we're going to look specifically at kind of the parts of a cone as well as the surface area of a cone and how we can solve for it. So we're going to start off with the big question. What is a cone? Well, we all know it's a great device for holding ice cream. Ha! Yeah, got to add a little bit of comedy in there. Here is a cone. Now, what you're going to notice about this cone here is that it looks very much like a pyramid, but it has a circular base instead of some other shape. So it's a specific version of a pyramid. It's got a circular base. It has a height. It has a slant height. It has on top, it's called a vertex or an apex. You can think of it either way. And that is a cone. So, in general, it's a pyramid with a circular base or a circle base. We're going to look and see how finding the surface area of this cone is done exactly the same way as a pyramid. It's just now we have a specific instance of a circular base, and the lateral area gets a little bit trickier. So, here is our cone. How do we solve for the surface area? Firstly, we have to take a look at the parts of it. Again, we're going to do base area plus lateral area is going to be our formula that we're going to use. And this here is our net of a cone. So we can just take it, break it apart, and see what does it look like. We have a circular base. We have a lateral surface, which very much resembles a triangle, which will help us going forward. So to find surface area, base area plus lateral area. Okay, it's our general pyramid formula that we're going to use. First step, how do we find the area of the base? Well, that in fact is a circle. So that should be fairly straightforward, and it is pi r squared. Okay, most of you should be able to understand that already. Hopefully you've gone through that and recognize it. Now, second part is our lateral surface area. So we want to find the lateral area. The diagram says lateral surface. I'm going to call it lateral area. It looks like a triangle, does it not? Yeah, but it has kind of a rounded base. So that part makes it a little bit tricky. But we're going to still consider it to be a triangle, and we're going to use our triangle formula, base times height divided by 2. All right, now the height of this triangle is just going to be our slant height. Okay, slant height is the same all the way throughout. We're going to use it as the height of this triangle, and the base of the triangle is going to be represented by that rounded curved portion of the lateral surface, which goes around the circular base. So the length of that side is the same as the distance around the circular base, which is the circumference. Now, because we're using radius in our circle or area of a circle, I'm going to use radius as well in the circumference of our circle. So I'm going to use the 2 pi r circumference formula. Okay, 2 times pi times our radius. And then the height is our slant height. So we're going to multiply it by s. And we're going to divide that all by 2 because it is a triangle. So base times height divided by 2. We've just replaced the base and the height with things specific to our pyramid lateral area. This part here, we can simplify a little bit. 2 divided by 2 is just 1. So we can remove those. They cancel themselves out, and we're left with pi rs for the lateral area. So what does our formula look like? Base area plus lateral area. Base area is pi r squared. Lateral area is pi rs. And that right there is our specific pyramid formula for a cone.